Hey y'all, welcome to video 18. Last time we covered LINQ basics, operations like where select and first. Now let's dive into the really powerful stuff that makes LINQ absolutely essential for everyday coding. Okay, so you've got the LINQ basics down, filtering with where, transforming with select. Great foundation. But that's honestly just scratching the surface. Today we're going deep with the methods that turn LINQ from useful to absolutely essential. GroupBy is like having sequels group by right in your C# code. Want to analyze sales by region, students by grade level? This is your power tool, and once you get it, you'll use it constantly. Need to match up data from two different collections? Join is like a database join operation. Match customers with orders, students with courses, anything that relates two datasets together. Sometimes you need multi-level sorting, sort by last name, then first name for ties. Then by chains, make this readable and maintainable instead of writing complicated comparison logic. Sum, average, count, min, max. These turn collections into insights. Combined with GroupBy, you've got serious analytical power that'd take pages of loop code otherwise. We need to talk about when LINQ actually runs versus when it just builds a query. This affects performance and behavior in ways that surprise everyone at first. Let's start with GroupBy, because once you understand this one, everything else clicks into place. GroupBy is probably the most powerful LINQ method after where and select. It organizes your flat data into logical groups based on any criteria you want. GroupBy takes your flat list and organizes it into buckets. Each bucket has a key, that's what you grouped by, and contains all the items that share that key, like sorting mail into mailboxes. Every group has a key property, that's the value you grouped by. If you group by customer ID, the key is the customer ID. Simple concept, but super important to understand. Here's the cool part. Each group is a collection. You can count it, sum it, average it, or loop through individual items. It's like having mini lists inside your query. Most of the time, you'll follow GroupBy with select to transform each group into something useful, like calculating totals or creating summary objects. See how we're creating an anonymous object with the stats? This is one of those things that's easier to see than explain. Let me show you visually what GroupBy does to your data. Okay, let me show you visually what GroupBy actually does. This usually clicks better when you can see the transformation. Here's our raw order data, 6 individual orders. Notice Alice has 3 orders, Bob has 2, Charlie has 1. Watch what GroupBy does with this. We group by customer name, then for each group we calculate the count and sum of amounts. The key gives us the customer name. Boom. 6 individual orders transformed into 3 customer summaries. That's the power of GroupBy, turning raw transactions into insights. This is exactly the kind of data transformation you'll do constantly in real applications, rolling up detail records into summaries. All right, next up, join. This is how you combine data from 2 different collections based on a matching key. Join takes 4 things. The second collection, the key from the first collection, the key from the second collection, and a function that combines matching items. It looks complex, but it's actually straightforward. This is an inner join. Only customers with orders appear in results. If a customer has no orders, they're excluded. There's also group join for left joins if you need that. That last lambda creates the result object. You pick which properties you want from each side. Here we're grabbing customer name and order details into one flat object. You can chain multiple joins together if you need to combine 3 or more collections. It gets complex fast, but it's possible when you need it. Let's see this one in action too. Visual examples really help with join. Here's a visual example of join. We've got customers in one table, orders in another, and we want to combine them. Imagine customers on the left, orders on the right. Alice and Bob have IDs 1 and 2. Orders reference those customer IDs. We need to match them up. We match onCustId from both sides, then create a new object with the customer name and order details combined. Now we've got customer names matched with their orders. Alice appears twice because she has 2 orders. Carol doesn't appear because she has no orders. Inner join behavior. Notice Carol disappeared? That's the inner join. No matching orders means no results. Keep that in mind. Sorting is more nuanced than just put these in order. Sometimes you need multiple levels of sorting, and LINQ makes this really clean. OrderBy sets up your primary sort order. This is your first level. Sort all employees by department first. Everything starts here. Within each department group, ThenBy sorts by last name. And if two people have the same last name, another ThenBy handles first names. Chain as many as you need. Order by descending and ThenBy descending lets you flip the order. Mix and match, highest salary first, but within ties, earliest hire date gets priority. Here's a gotcha. Calling OrderBy twice doesn't create two-level sorting. The second OrderBy replaces the first. Always use ThenBy for secondary sorts. That last point catches everyone. I'll show you the mistake in a minute so you know exactly what to avoid. This is one of the most common LINQ mistakes. Let me show you what goes wrong. On the left, that second OrderBy completely wipes out the department sort. You end up with just last name order. All that department grouping, gone. ThenBy says, within the existing order, sort by this next. It respects what came before and adds to it. This is what you actually want. This mistake is so common I've seen it in production code at multiple companies. Now you know what to look for. Aggregate functions collapse a collection into a single value. These are essential for any kind of reporting or analysis. Sum takes a selector lambda and adds up all the values. Total revenue, total quantity, total anything. Pass it the property you want to sum. Count without a parameter counts everything, but you can pass a predicate to count only items that match a condition, like counting orders over $100. Super handy. Average calculates the mean, min and max find the extremes. All of them take a selector so you specify which property to analyze. Simple but powerful. Watch out because average, min and max throw exceptions if the collection doesn't have any items. When in doubt, use the any method to check first. Where these really shine is combining them with GroupBy. Let's look at that pattern. This is where LINQ becomes genuinely powerful. Combining GroupBy with aggregate functions gives you instant data analysis capabilities. Here's our product sales data. Different categories, different prices, different quantities. Let's get category level insights. Group by category, then for each group calculate product count, total revenue, and average price. All in one query. Hardware has more products, but similar revenue to software. Software has higher average prices. This is the kind of insight that used to take pages of code. Imagine doing this with nested loops and counter variables. LINQ makes it declarative. You say what you want, not how to calculate it. Here's something that trips up almost everyone learning LINQ. When you write a LINQ query, it doesn't actually run. It just creates a description of what you want. The query only executes when you actually try to use the results, like in a for each loop or when you call ToList. This is called deferred execution, and it's both powerful and dangerous if you don't understand it. Let's break down which LINQ methods are deferred and which execute immediately. Where select, order by, they're all deferred. They return IEnumerable, which is just a query definition, not actual results. Chain them all you want. Nothing executes until you enumerate. To list, to array, to dictionary, these force immediate execution. The moment you call them, the entire query runs and you get real data back. This is how you capture a snapshot. Anything that returns a single value, first, count, sum, any, has to execute immediately. You can't defer a count, you have to actually count things. Rule of thumb, if it returns IEnumerable, it's probably deferred. Anything else executes immediately. Here's the most common performance trap with deferred execution. On the left, expensive is a query, not data. Every time you use it, count, for each, anything, the entire query runs again. If getAllOrders hits a database, that's 2 database calls. Imagine this in a loop or with multiple operations. The query might run 10 times when you expected once. Performance goes through the floor. When in doubt, to list early and reuse. It's almost always the right call. Let me save you from the performance traps that catch everyone when they're learning LINQ. Always, where before order by. Why sort 10,000 items when you only need 100? Filter first to reduce the dataset, then sort what's left. Order of operations matters for performance. Don't use count zero to check if results exist. Use any instead. It returns true as soon as it finds one item instead of counting everything. Way faster on large collections. Only need the top 5? Use take 5. Combined with OrderBy, it's smart enough to find just the top 5 without fully sorting everything. Don't process more than you need. Putting a LINQ query inside a loop that runs 10,000 times, that query might execute 10,000 times. Extract it outside the loop, or ToList before the loop starts. And one more time, because it's so common, chaining multiple OrderBy calls doesn't create multi-level sorting. The second one replaces the first. Use ThenBy for secondary sorts. Most LINQ performance problems come from multiple IEnumeration or poor operation ordering. Keep these patterns in mind, and you'll be fine. Here a sample that pretty much could be from production code. We execute the filtered query once with ToList, then use that snapshot for all our calculations. Multiple GroupBy operations, aggregates, rankings, all building on the same data. ToList at the top means getAllSales only runs once, no matter how many analyses we do below. See how readable this is? That's the power of LINQ. Complex data analysis that reads almost like English. All right, let's recap the advanced LINQ concepts we've covered. GroupBy turns flat data into categorized insights. Combined with aggregates like sum and average, it's your go-to tool for any kind of data analysis or reporting. Join matches up data from two collections based on keys. Inner joins are most common. Remember, no matching key means no results for that item. Complex sorting is clean and readable with OrderBy and ThenBy chains. Never chain multiple OrderBy calls, use ThenBy for secondary sorts. Deferred execution is powerful but tricky. Methods returning IEnumerable are deferred. When in doubt, ToList once and reuse the results. Filter before sorting, use any, not count, 0, and avoid multiple IEnumeration. These simple rules keep LINQ fast. Next up, we're switching gears completely. Time to talk about multi-threading and making your programs do multiple things at once. Here's a challenge that'll cement these advanced LINQ concepts. This one's meatier than previous challenges. Build a console app with sales data. Include product name, category, quantity, price, date, and region properties. Generate at least 100 sales records spanning multiple months, categories, and regions. Use GroupBy to group sales by month, then calculate total revenue and unit count for each month. Display as a simple table showing the trend over time. Group by category and calculate total revenue, average sale price, and units sold per category. Order by revenue descending to see top performing categories. For each region, find the top 3 products by revenue. This needs GroupBy nested or chained creatively. Figure out what approach makes sense to you. Use stopwatch to measure execution time. Try running your analysis with and without ToList on the filtered data. See the difference multiple IEnumeration makes in real numbers. This is challenging, but it mirrors real work. Dashboards, reports, analytics, they all follow these patterns. Take your time and don't worry if GroupBy feels tricky at first, you'll get it eventually. Anyway, thanks for watching and stay tuned for more.